Greetings again, and welcome to lesson 3. We're still doing forces and Newton's laws, okay? So this is term 3. We're going to prepare for term 3, okay? Hopefully this helps you out, okay? And again, go to lesson 1 if you want to see a comprehensive list of formula. I wrote it here, and I also gave you the symbols, what they mean, and I explained everything in lesson 1, okay, on Newton's laws. So let us do question 4 here. Again, this is from Northwest, November 2024, okay. So question 4 here is, this is a case of an incline. So object A is hanging and object B is on an incline. So the surface here, the surface is not horizontal here. The surface is an inclined surface. And they gave us an angle here of 35 degrees. So let's read the question together. They say two blocks, A and B, are connected by a light inextensible string, are held stationary as shown in the diagram below. Block A has a weight of 19.6 Newton and block B has a mass of 18 kgs. The kinetic frictional force on block B is 20 newtons. Then I say upon release, block A starts to accelerate upwards. Okay, so and block B accelerates down the smooth slope of angle. The smooth slope of angle 35 degrees to the horizontal. Okay, so they say the smooth slope. Okay, I think this is a mistake because they say the kinetic frictional force on block B is 20. So there is frictional force. Okay, it's not a smooth slope, but I think that's a typing error. I think, yes. And then, because it cannot be a smooth slope if there is kinetic frictional force on block B. Okay, so now 4.1, they say state Newton's third law of motion in words. Newton's third law, what does it say? Newton's third law says when object A exerts a force on object B, object B will simultaneously exert a force of equal magnitude on object A on object A, but in the opposite direction. In the opposite direction. So yes, this is what it says, okay, in Newton's third law. When object A exerts a force on object B will simultaneously exert a force of equal magnitude on object A, but in the opposite direction. 4.2, what does it say? Then for 4.2, they say, draw a labeled free body diagram showing all the forces acting on block B. Block B is here, okay? So block B has a strain this side, okay? So meaning there's going to be tension this side, and they say block B is sliding down. So the forces gonna be like this. So for block B, there's always gonna be weight. You can say weight. So the weight is straight down. Okay. So there is the weight of the object going down. You can say weight, or you can say force of gravity. One of the two. And then the normal force. The normal force is always, it always makes 90 degrees with the surface. So it's always perpendicular. So the normal force will act that way. It makes 90 degrees with the surface. This is the normal force. Then there is the tension. The tension which is going back like that. And there is also the kinetic friction. So there is the tension from the strain going the other side. And then there is also kinetic friction, FK, kinetic frictional force, the one that gave us, the one that was given for 20 newtons. So this is it. This is the free body diagram. This is 4 marks. It's 1, 2, 3, 4. So yes, this is our free body diagram. So the normal force is always perpendicular, meaning it makes 90 degrees with the surface. If the thing is going down, it means the frictional force is always in the opposite direction of movement. That if the object B is going down, it's going down like that, the frictional force will go up automatically because it's always in the opposite direction relative to the motion of the object. Okay, let's go to 4.3. What are we required to do here? 4.3, they say calculate the magnitude of the acceleration of the two blocks. Okay, so we should apply Newton's second law for each block. Okay, so for A, there are two forces. there is the tension going up, and then there is the weight going down. Now, again, here's the other part that is confusing. Okay, which force becomes positive and which force becomes negative? The tension is going up, okay, because this thing is going right. Object A is going up. Okay, so that is the direction of movement. So to make things easy, we assume the direction of movement is the positive direction. So the A is going up and B is going down, meaning we take the direction upwards as positive. And here we take it for B. For B, we're going to take the direction downwards as positive. Okay, so we apply Newton's second law individually for each block. Okay, so let's begin with A. So now what's happening at A? So we're going to say for block A, okay, I'm going to say F net. The net force here equals to MA. And then we say that the tension minus the weight will be equal to MA. So the mass here is how much? Block A is it given? The mass is not given for block A, okay? But they gave us the weight. Okay. If they gave us the weight, we can find the mass, isn't it? Equals to, so equals to MA. So this means that, therefore, the tension here will be equal to weight plus MA. Okay? And then the weight, the M here can be replaced by what? We can say W plus, and then we say weight over G, okay? And then multiply by A. Because why? Because we know that weight equals to mg, okay? So we can just change the subject here. We can change the subject. If we divide both sides by g, then we find m, okay? So then this is going to be equal to, they gave us 19.6. Is it 19.6? Yes. The weight. So the weight here that they gave us, yes, it's 19.6. So then we have 19.6 plus 19.6 over 9.8, and then A. And then this is going to be equal to 19.6 plus 2a. Yes. So this is for block A. Okay. Now, if we go to block B, what do we have here? So let's make a dotted line here. And then for block B, we have to write down all the forces. We have to write down all the forces for block B. So then we say the net force again. Okay. Net force equals to MA. And so for block B, okay, which forces are acting downwards? Which forces are acting downwards? That is, again, the gravity, there is a component of gravity which is parallel to the surface here. So there is Fg parallel, the component of gravity which is parallel to the surface. And then there are two opposing forces. According to the diagram, there is the tension going up. There is also kinetic frictional force. So we have for B, we're going to have Fg parallel minus tension minus kinetic friction equals to 18A. The mass, they gave us 18. And then we are going to have mg sine theta, that is the Fg parallel, minus tension minus kinetic friction, which is 20, they gave us 20, equals to 18A. So the kinetic friction here, we were given 20 newtons, okay? They said the kinetic friction force is 20. The mass is 18. The kinetic frictional force on block B is 20. Okay, so we just substitute everything. And then the angle of inclination is 35, I think. Yes, we have 35 degrees. So we have to come here and we substitute 35 degrees. So if we swap, we can take T that side to make T the subject. So then it's going to be therefore mg sine 35 degrees minus 18A and then minus 20 equals to T. So the T comes to the right side of the equation and the 18A comes to the left. So then from there, we can substitute here. We can say 18 and then we multiply 9.8 sine 35 degrees minus 18A minus 20 equals to T. So now what we have here is that T is the subject for B and T is also the subject for block A. So the two objects have the same tension because the two objects are attached by the same string. So the tension in both, the tension is the same. Okay, so we can equate the tension for A and for B. So then we can come here and we equate the two tensions so that we can find acceleration. So we then can say T equals to T. So this means we can take the side 19.6 plus 2A equals to the tension on the other side, which is 18 multiplied by 9.8 sine 35 degrees minus 18A and then now when we have this, then we can find A. We can group the A's one side and then we can group the numbers the other side. So we can bring 18A we can bring it this side and then we take 19.6 the other side. So it's gonna be 18A plus 2A equals to 18 multiplied by 9.8 sine 35 degrees minus 19.6 minus 20. Okay. So then after that, is therefore 20A equals to 18 multiplied by minus, so we minus the 2 here, we get 39.6. So it means therefore, then we can get A, we can divide by 20 here. We can divide by 20 on both sides. So it's 18 multiplied by 9.8 sine 35. 35 degrees minus 39.6 and divided by 20. And then get the answer. We get the acceleration. So this whole thing can be used, we can use a calculator here to get the answer. So we type the whole thing into the calculator. Then I get 3 point to 2 decimal places. It gives me 3.08 meters per second square. Yes, this is what I get. 3.08 meters per second square. So that is 4.3. So that was 7 marks. Okay. You had to find, so you had to see that in order to find A, we don't have tension on both sides. Okay. We don't have tension for B and we don't have tension for A. So what we can do is we can make tension the subject on both sides. So tension is the subject here on A, and then tension is also the subject on B. And then the two tensions are equal to each other because they are connected by the same string. So when you equate the two tensions, you eliminate the tension from the equation and you are left with numbers and A. So then you can find A when the tension is gone. Okay, you can group the A's one side and then take all the numbers and you group them the other side. And then you can find A. You can make A the subject here and then it gives you the answer. Okay, so that's what you had to see, that you don't have the tension. So the tension had to be eliminated somehow because we don't have it. Okay. Let us move to 4.4. 4.4, they are asking us to find the tension in the string, I think. So 4.4, what is happening? So let us look at 4.4. 4.4, they say determine the determine the tension in the string connecting the blocks. Okay, so if we have the acceleration, it would be easy to find the tension. We can use this, okay? So we can say tension equals to 19.6 plus 2a. And so we can substitute the a here. So it's going to be 19.6 plus 2 into 3.08. And then it's going to be 25.74 newtons. 25.74. That's what I get. So yes, that was it. That was it for question 4. Okay. And that was it for lesson 3. Leave your questions in the comments. Let me know if you have any problems. Okay. Yes. Let me know if you find anything confusing, and I will address your problems in the comment section. Okay. Until next time, take care, and I will see you in lesson 4. Cheers.